Hi there, Mr. Sutton here, bringing you the Algebra 2 7-3 Part 2 homework solutions on multiplying and dividing rational expressions. For this question, we're trying to simplify this product of rational expressions. To start things off, I'll just think of this second thing as being like a fraction with a 1 in the denominator. Now let me factor everything I possibly can and then cancel out any common factors. For the upper left, we need things that multiply to negative 12 and add up to negative 1. 1 and 12 doesn't work, 2 and 6 doesn't work, 3 and 4 works, positive 3 and negative 4. For this x squared minus 16, I can square root those and use a plus minus, so x plus 4 and x minus 4. And then for this last one, things that multiply to negative 8 and add up to 2. 1 and 8 doesn't work, but 2 and 4 does. If we have negative 2 and positive 4, that adds up to positive 2. So what can I cancel? Well, the x minus 4s that are in the same fraction, those can go away. And also we can cross-cancel these x plus 4s. So that leaves us with an x plus 3 times an x minus 2 in the numerator. And the denominator is just this 1 that we don't have to write. So this is it. Now we did cancel out the x plus 4 and the x minus 4. So that means that negative 4 and positive 4, those x values, must be excluded from our final function. For this problem, we're trying to multiply these together. Let me start by factoring out whatever I can. My right fraction here is already fully factored. On the left, this x squared minus 25 can be broken down using a plus minus shortcut. So if I square root those, I have x plus 5 and x minus 5. Now this 3 minus x down here looks like it's fully factored, but in fact, if you wanted to reverse the order of those terms and make it match this x minus 3, you can take out a negative 1. So if I do that, then this negative x becomes a positive x, and this positive 3 becomes a negative 3. So now what can I cancel? These x plus 5s can be cross-canceled, and now these x minus 3s can also be canceled out, which is nice. That leaves us with an x minus 5 over a negative 1. And if I want to, I can actually simplify that a little bit more and divide both of these by negative 1. So that would end up being negative x plus 5 or 5 minus x, either way of writing those. Now there is one other thing we have to deal with here. We canceled out a few things along the way, these x minus 3s and these x plus 5s. So that means that 3 for this one and negative 5 for this other canceled out factor, those both have to be excluded. We can't plug in those x values because they make the original function undefined still, even if this new one isn't affected by them. For this problem, let's go ahead and factor everything we can and then cancel out common factors. In the upper left, I need two things that multiply to negative 4 and add up to 3. That would be 1 and 4 if we have negative 1 and positive 4. In the lower left, things that multiply to 4 and add up to 4, well, that would just be positive 2 and positive 2. So I can write x plus 2 quantities squared. And then in the upper right, I can take out a common factor of 2x, leaving me with an x plus 2 up there. And then in the lower right, things that multiply to 3 and add up to negative 4, that would be 1 and 3 if they're both negative. So x minus 1 and x minus 3. So it looks like these x minus 1s can cancel. And what else? Well, the x plus 4 can't, but one of these x plus 2s, this x plus 2 and one of these down here can cancel out. So what's left over then is a 2x and an x plus 4 in the numerator. And we have an x plus 2 and an x minus 3 in the denominator. What do I need to exclude here? So definitely I have to say x does not equal 1 because of this x minus 1 that we canceled out that's no longer affecting things. How about the x plus 2 that we canceled out down here? Well, normally we would have to say x does not equal negative 2. However, there is still an x plus 2 in the simplified function. So the x value negative 2 makes the simplified undefined as well as the original. So for that reason, because it's still affecting our simplified function, we don't have to spell it out. You could if you wanted, but it would be redundant. To start this division problem, we're going to multiply by the reciprocal, so same change flip. So we keep the same first fraction, change this to multiplication, and flip this second fraction to be 8x to the fourth over y to the seventh. And then if we look closely here, there's nothing to factor. It's just going straight to canceling common factors. All we can do is cancel out this y with one of the y's down here. I'll do the y down in the lower left. So that ends up being y to the seventh down there. And then multiplying straight across, 32 times 8, that's going to be, let me think, 256. And then x to the third times x to the fourth, that's x to the seventh, adding the exponents. And then y to the seventh times itself is going to be y to the 14th, 7 plus 7. Now the only thing I canceled was one of these y's, so we might think of saying y does not equal 0 as part of our answer. We actually don't need to spell that out though, because if I plug in 0 for y, it will still make the simplified function undefined, so we don't even need to mention that. For this problem, since it's division, we're going to start by changing that into multiplication by using the reciprocal. So same change flip, keep the first fraction, make this multiplication, and then flip the second fraction to 4x squared, or 4x cubed rather, over x plus 2. And now that we've got multiplication, let's go ahead and factor and cancel out whatever we can. So the right fraction here is already as factored as it's going to get. On the left side though, the upper left, things that multiply to -6 and add up to -1. 1 and 6 doesn't work, but 2 and 3 will if we have +2 and -3. In the denominator, I can take out a 2 and an x cubed. That leaves me with an x minus 3. And let's see what I can cancel. These x plus 2's can go away. So can these x minus 3's. And also, 4 over 2 is going to be 2, and these x cubes cancel completely. So there's just a 2 left up there. So when the dust settles, my numerator just has a 2. My denominator has nothing, so it has an invisible 1. So this is all just 2. So that definitely does appear to be simplified. For once, simplifying actually does make it look simpler. We do have to exclude some things, though. So we have to leave out x equals 0 because this x cubed that got canceled. This x minus 3 means we have to leave out x equals 3. And also we have to leave out -2 because of this x plus 2 that we canceled out. To start this division problem, let's multiply by the reciprocal of this second one. So this is going to be my first fraction times 1 over x squared minus 6x plus 9. And now let's go ahead and factor. We don't need to do anything with the 1 and the x plus 4, but in the upper left here, things that multiply to -6 and add up to -1, that would be +2 and -3, so x plus 2 and x minus 3. And down here, multiplying to 9 and adding up to -6. Well, let me think. 1 and 9 doesn't work. 3 and 3 works if they're both negative. So x minus 3 squared then. And now I can cancel this x minus 3 with one of these x minus 3's, just one of them though. And that's about it. So that leaves us with x plus 2 over x plus 4 times x minus 3. Is there anything to exclude? We might think about excluding an x equals 3 because of these x minus 3's that we canceled, but if I plug 3 into the simplified function, it still makes this undefined. So because our simplified function already has that covered, we don't have to explicitly write x does not equal 3. To start off this division problem, let's turn it into multiplication. Same change flip. So keep the same fraction for the first one, make it multiplication, change it to that, and then flip that second one to be x squared plus 2x minus 8 over x squared minus 3x minus 18. Now that we've got multiplication, let's do a whole bunch of factoring and canceling. In the upper left, things that multiply to 18 and add up to 9. 1 and 18 doesn't work, 2 and 9 doesn't work, 3 and 6 works if we have x plus 3 and x plus 6. In the lower left, things that multiply to 8 and add up to 6. That would be +2 and +4. In the upper right, things that multiply to -8 and add up to 2. Well, now we need -2 and +4. And then down here, things that multiply to -18 and add up to -3. Well, now we need x plus 3 and x minus 6. So what cancels out of this? X minus 3's can cross cancel. Let's see, x plus 6 can't cancel, x plus 4's can cancel, and it looks like that's about it. We have some near misses on those other ones. So we end up with x plus 6 and x minus 2 in the numerator, and x plus 2 and x minus 6 in the denominator. And we have to exclude negative 4 because of the x plus 4 being canceled, and also negative 3 because of the canceled x plus 3. On this one, we're told that the total amount, E, of educational technology expenditures is given by this E of t function, and total number of students, P of t, is given by this other function down here. We want to know, and this t is the number of years since 2000. So we want to know the annual educational technology expenditure per student in 2022. So basically we have to plug 22 into both of these functions and then divide, let's see, it's got to be E divided by P. We need the expenditures divided by the number of students. So we're doing E of 22 over P of 22. I'm going to do all of this on Desmos. So let me fire Desmos up, and I'm going to first enter the E function in there. So E of t equals, and now let me make a fraction, and we'll do negative 6.984 t plus 550, and that'll all be over 1 minus 0.027 t. So that's one function. The other function, let me just move over here so I can see it. That's P of t, and that equals 0.006 t plus 2.09. And now once I've got those defined, I can just easily plug 22 into both of them and divide. So I'll make a fraction. Let me just do E of 22 for the numerator, and now I'll do P of 22 for the denominator, and that ends up being about $439.35 that we're spending per student.